Well, on Julia Twitter recently, the Julia language account tweeted out, what is one or more missing tools in your Julia development workflow that you wish existed but doesn't? Here's an interesting apply. Say, well, we want XYZ and an R dplyr like full working package. And I replied, well, you can use data frames meta pipe, and pairs pipe. I said, well, thanks. Any examples of using those packages together? And also, I'm pretty sure dplyr development in Julia is one of the first things somebody coming from R Googles when they looking at Julia for examples. Okay, I thought that was cool. Then I looked through the dplyr library, a package in R, and try to find something that would be interesting to look at. And I found this across function, which is getting a lot of hype on Twitter in dplyr. So I want to walk through how the across works and how to implement across in Julia. So first things, in R, I just load the dplyr library, and I'll look at the dataset that we'll be working with today. It's the iris dataset. Comes with 4 columns of numerics and 1 column of categorical column, which is the species. And I'm going to work through all the examples that are in the dplyr across function. So if you look at the doc for across, you see all of these examples. I'm just going to walk through them and show you how to implement them in Julia. Okay, first things first, what is across even doing? Let's look at this example. It's summarizing the iris dataset by first grouping by species, and then in the summarize, they do this across. So across function has 2 arguments here. One is this, starts with sepal, and then mean. So what the first one means is that it's a filtering criterion for the column names. So they only want to apply the mean to all the columns that starts with this. And on the right hand side, the second argument is basically all the functions you want to apply. So you can have more than one function if you want, but in this case they just applied one function. So that's what you get when running the code in R. So let's see how that's done in Julia. So we're going to start by loading all the libraries. So data frame, statistics, load the pipe function, which can replicate the Julia's pipes syntax provided by Margarita with a little bit of a difference. And I load the R datasets library, which loads the datasets iris. And I like using the floating table view to view the data. So if I run that, this is what I will see. You see that the data in a floating window, so I can move it around if I want. Okay, so first things first, I want to replicate this, which is group by, and then summarize it and apply mean to columns that starts with that. So firstly, I'll show you how to filter for column that starts with this. It's almost exactly the same. So I take the names of the table. This is a function as well, and I just run filter on it. So you see that now I'm left with only 2 names. And putting everything together, I will use the pipe to pipe this into the next row, and the results of all of that will get piped into the underscore here. And this symbol is basically nothing but the pipe symbol plus a greater than. But if I put them together using my font, they will look like just one symbol. So very simple. I just run that, and I use the combine, which is almost the same as the summarize function in R. And I will basically put all the column names I want and use the pairs to pipe them into mean. So the pair symbol is nothing but equal sign and greater than. But if I type them together, they will become this pair symbol. And this dot means for every column that you get here, apply the same the same thing, which is mean. And this is called broadcasting. So basically it's the same as the R recycling behavior. If on the right hand side you have only one item, but if there's 3 items here and 2 items here, this broadcast will not work. It's not like R recycling exactly. It's only the same as R's recycling when on the right hand side there's only one value. So if I run this, as you can see, it generates exactly the same results as over here, except it's got this underscore mean. And later on we'll show some examples where that's no longer necessary. Okay, so that's not too bad. And the next example is, apply the is vector, wrap it in a where, that becomes the first argument of the across, and then change it to a character. What this means is find all the columns where it's a vector and convert them to character or string. So if I run this, you see the species is no longer a categorical column, but now a string column. And you notice this where function here. So if you wrap a function in a where, this becomes looking for columns instead of here where it's filtering on column names. So this is the filtering by content of the column. So how do I do this in Julia? Well, it's a bit more verbose. Firstly, I would take the table and apply each column function to it. That will make it into an iterator. Then I can broadcast that to find out the types of each column. So you see if I run that, it will tell me that the types of each columns are array of float, 4 times, and the last one is a categorical array. And to check if they are a categorical array, I just have to use this subtype checking operator. So this operator will return true if what's on the left hand side is a subtype on what's on the right hand side. And of course there's more than one values here, so I just use the broadcast version of that. If I run that, I get exactly the results I want, which is false, 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 true, because only the last column is a categorical. And if I just run the names on the table and then use the Boolean values that I get from above into it, then I can filter for names that I want. So if I run that, that will return species, which is the column that I want. So how do I convert a column of categoricals to strings? There's typically 2 ways that you can do that. One is by typecasting, just by putting the type vector string in front of a array that's got categorical array that's got string as values. Yep, so you can see that gets converted, and later on we'll show another way as well. But you say that, well, that's actually not very satisfying. It's a bit verbose, and I need to use temporary variables. In R, it's just like that. I guess in dplyr there's a lot of magic in there. For example, this where keyword. So if you wrap everything in where, then it checks the content of the column instead. So these are a little bit of magic, but once you get used to the magic, this is a lot more succinct and very expressive. So we'll come back to this exact example at the end of the video and show you how to do that in R. I'll show you how to do that in Julia as well. Okay, well, let's look at the next example. Next example is in R as a per style formula. The first part is exactly the same as before, and the last part is defining a mean function but removing all the NAs. And the per syntax is basically where you put a tilde in front of the formula, and you can refers to the argument of the function as .x and .y. If you have more than one, you can do .1, .2, .3, etc. If you didn't use per syntax, you just have to do a bit more typing. So for example, this would also work. So if you do function, the first argument of the function is x, and you apply exactly the same thing. So the per syntax is just a more convenient way to define functions. How do you do this in Julia? So Julia already comes with the ability to define anonymous functions, which syntax is X, and then points to whatever you want to do on the right hand side, where X is the first argument. Again, due to the font that I use, this symbol is nothing but minus sign and greater than sign. If you type them together, it becomes that symbol. Okay, so, and of course I applied the skip missing, which achieves the same effect as na.remove in R. So run that. As you can see, I will get the same results as if I ran this in R. So the results are exactly the same. Cool. Next example, a named list of functions. So this time is basically same parts and a list. And it's not just a list, it's a list with name. So mean equals to mean and SD equals to SD. So let's run that. As you can see now, the result is the column names plus the name of the in the list appended at the end. Okay, so let's see how to achieve this in Julia. We'll be doing this. So let's have a try of iris group by that, combined with this, and then broadcast to mean and standard deviation. Now this doesn't really work in Julia because you see the output is not 4 columns, it's just 2 columns. So yeah, it's just 2 columns, and I just realized that it's not actually showing 4 columns on this side. It's because I probably would have the font a little bit too big, but let's just do it like this so you can see. So you can see what's happened. Yep, you can see there's 4 columns if I run this now. Yep. So that's what it should look like. So what's happened? You see this broadcasting, it's broadcast, so it matches the first column name with the first function, the second column name with the second function. But actually what you want is a product of these. So how do I achieve a product of these? So what I would do is I'll just use the list comprehension in R, which is this particular array here. And this array I've constructed by doing a for inside the array. So for name in this filtered name section, and for function in one of these. And if I do this syntax where I do for and then something in something and something else in something else separated by a comma, it essentially do a product of these 2 iterators. And what I do with the product of these 2, well, I put the name pipes to the function. So if I just run that, oh, I can't actually run that because the names underscore here is piped from the past. So I should just do names and then iris, and you can see this is what it generates, you know, the name to a function, name to a function, name to a function for all the possible combinations. So if I do that in a combine and I use a ... to splat the 4 options onto the combine function, then I achieve what I want in the R version. You can see now I output exactly 4 columns and mean, standard deviation. But this is a bit verbose and a bit hard to read. So you can probably do better by defining a function. So this is what I've done. I've defined a function called dplyr across. It takes the names and functions and do exactly the same trick, which is, you know, do a list comprehension of the product of these 2. And instead of wrapping it in an array, I wrapped it in a tuple. So, but it's exactly the same idea. So I do that. So now instead of calling this complicated thing, I just call it dplyr across. I supply the name I want and the functions I want and then splatter them. So that's it. So now I can achieve exactly what I want in R. But I'm still a little bit not fully satisfied with this. So I want to show you a feature in Julia involving multiple dispatch that can do this in a more succinct way. So the first thing I do is I define this type using the struct, and this type contains only 3 things inside it, which is the input names, function, and output names. And the input names and output names are not exactly vectors of strings. They are basically special types, and you see what they are. And I'm going to have a very simple constructor, which is that if you give me the input name and the function, I'll just construct a new object with the input name and function and put nothing into the output name. So now we'll deal with the output names a little bit later. So what do I actually want to do? I want to make sure that my combine function can accept a dplyr across object and do the right thing. So the way to do that is I'm going to import the data frames combine. Once I import it, I can define a new function for data frames combine, but this time accepting my type that I will define, which is dplyr across. And what do I want to do with this? Well, the first thing first is I will take all the names from the data frame and I will apply a filter, and this filter comes from dar.inName. Dar is a dplyr across object, and the inName is basically the function that I would apply to the names to filter it. In this case, I would, for example, supply it with starts with that, and it will just filter it and give me only column names that satisfy that criterion. I have not implemented the branch where the output names contains some value, so that's why it's not implemented yet. So I only deal with the easier case where this is not defined. So what I do this product trick in the list comprehension. Again, I create this column to a function, and the input column comes from here, and the function I want to apply is basically what's stored inside the fn of the dplyr across object. So I access it using dar.fun. Once I got this pairs, I just splat into a normal combine function, and it will just work. So let's see how that works. So I do this, and instead of writing what I have here, which is filter, etc., 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 I just write this dplyr across, the function to filter the column names with, and the functions I want to apply to these columns. So run that, and now you can see I generate exactly the same output as before, but the code is now a lot easier to read, as long as you know what dplyr across is doing, of course, but and a lot shorter as well. Okay, so let's look at the next example. So which is use the .names argument to control the output names. So you can see here now in the R code is basically this part is the same as before, but they call it mean and they run this .names. So the .names controls the output name. So if I run that, you can see that the output name now follow this pattern, which is mean underscore the column name, and that's specified by this pattern. Basically replace, every time you see this, replace it with the actual column name. So that's what this means. So how will I go about implementing that in Julia? So let's continue with the same code that I had before. So this time I'll make the constructor contain an optional names. So I construct the same object as before, dplyr across, but if the name is nothing, I just put it into there. If the name contains something, I'll also put it into there, which is the third item within the object, which is the output names, but by default it's nothing. So I have to change the data frames combine implementation, and this time I'm implementing this branch as well, which is the branch where the output names is populated with something. We have already seen this implementation before. Very simple. I just filter the input names, and if the output names is nothing, do as what we saw before. If there is an output name, this is what I'm doing. I'm going to generate the output names. How do I do that? I'm going to look at the output names supplied in the dplyr across object. Look at the output names, which should be in the form of a string like this. And what I would do with this string is, firstly, I'll replace curly bracket curly bracket with the actual column names, and I'll replace every time I see this fn with the string of the keys of the function. And how do I do this? I wrap it in a array comprehension, a list comprehension, and I generate all the combinations of column names and keys of the functions. So why keys? So keys, basically, if your list of function is named, then the keys will return the names. Otherwise, keys will return the values 1, 2, and 3, and 4, etc. So that's how I generate the output column names. And once I generate the output column names, I create a new in function out iterator. And this iterator has a very simple form. I take the product of the input columns and the functions from the dplyr cross object, and I zip them together with the output columns. Well, the output columns are computed from the product of the input columns and the functions. So this should have exactly the same length as the product. So I zip them together, that will be exactly the same length. And I just iterate through this iterator. And this iterator by construction would have values of this form: input column, function, and output column. So I iterate over this and generate what I need for the data frame syntax, which is input column pipe into function into output column. And that's my pairs. And I splat the pairs and call combine. So that's it. That should just work. So let me just run these functions, and now you can see I'm doing dplyr across the filtering function, the mean, and how I want it to be named, which is mean underscore col. Run that. As you can see, I generate exactly the same output as in R now, just by defining this object and overloading the combine to make it work with my dplyr cross object. Okay, next example. Well, the next example is basically, it's the same as before, almost, except they group by species, do a summarize across this, but now they give a list of functions with names. So mean equals to mean, st equals sd, and the output name should now follow this form, which is column dot function. So let's run that. Yep. So you can see the output is basically the input column name dot function name. Oh, I haven't run the right thing. Yeah, this is the correct one. So input column name, name of the column, name of the function that you apply. Now this name comes from the left hand side of this. So if I change it to mean1 and st1 and run that again, you should see that yeah, it takes the name of the left hand side, not the right hand side, because the right hand side technically is just a function. It doesn't really it's not a name. So that's why if you don't supply the name you see next, the names will become 1 and 2 instead of the name of the function. So let's keep it like this. This is the expected output. Oh, let me run that again. Oh, sorry. Yeah, I should keep them the names. Run it. Yep, exactly the same as output. Okay, so now that I've implemented the functionality in Julia, I can just run that. So exactly the same as the R syntax, the dplyr syntax. I do dplyr across mean names equals to that. That already works. I showed before, and a more complicated form like this will also work, which is matches the results from R. But of course, you don't really want a dot in the column name in Julia, so just replace it with underscore. That's the recommended way. So you can see exactly the same results as before. To the last example, which is basically I've shown already, which is the same code, but when they supply the list of functions, they don't give the function a name. So what will result is that the outcome would be column name fn and then 1. The fn comes from this here, which is the string literal, and the bracket fn becomes the number 1, 2, 3, 4, etc. So that's how this comes from. So same thing in Julia. If you run the dplyr across without giving a name to each of the functions, you get exactly the same results. I've replicated this behavior, so now you can see just by using the dplyr across object, we can get exactly the same results. Well, how do we make it easier to use? Well, you make it into a package, of course. So I've registered this package called tidyverse, and you can already install that. However, you may have seen in the screen before that there was a using dplyr. So dplyr was the package name I wanted to register, but it was a bit too short. It's only 4 characters. So I wanted to use something a bit more unique and something that stands out, and also not too common. So I just chosen the name tidyverse, and this is how you can use tidyverse. Just using tidyverse, and then as before, we pipe the iris into a group by and do a combine, and then there's the across that's defined within tidyverse. And I'm going to do exactly the same thing as before and just compute the mean and standard deviation and output the name as such. So I run that, you can see, yep, it starts. And exactly the same as before, except this time I'm going to start using the across, which is the lowercase a. So they are synonyms of each other. Technically, using the across, I'm creating an object. So the capital case is the better one. But just for ease of use, I've made a cross synonym as well. And by default, these function names across are not exported from tidyverse. So you have to use tidyverse dot, and I'll show you another way to use that. So you have to do less typing to get access to these features. So run this one. You can see, it's exactly the same as before. And the only difference is I'm using across. So do you recall this case that we skipped at the beginning? It was basically taking iris and then do a mutate across where the column is a vector and convert that to a string vector. And we used to do this where we just go for each column of iris, check the type of it, see if the type is a subtype of a categorical array, and then filter out all the names that satisfy this condition here, and apply the transition using this dot pairs pipe into the function that does the string casting, or into the string. So we can do this as before. It will continue. It will still work. As you can see, the last column species got converted to string. So now I'll show you how to do that in the tidyverse package. So you can continue to use tidyverse, but to save on typing, you can just do HV, for example, equals to tidyverse. So now each time you refer to HV, it's the same as referring to tidyverse. Just a little bit less typing. So you can do pipe iris and use the transform, which is the same as the mutate in dplyr. And you pipe the iris into it, and you do a cross, and you can do hv.where. That's exactly the same as the R syntax, and you just have a function that checks if the column is a subtype of categorical column. And as a reminder, every time you use where, and the function that you pass in will be applied to the content of the column, not just the name of the column. And of course, once you've filtered out the column that you want to apply the action to, the action you apply it to is the vector casting. And of course, in Julia, there's no function that is convenient for checking the categorical types, or rather checking whether the column is a subtype of categorical array. In R, you can do that using the isVector function. So in Julia, I'm just going to define my own function, which is very easy to do anyway. So say isCatArray, just apply exactly the same logic above. So this function will check if a column is a subtype of categorical array. So now I simplify the code even further. I go iris pipe into transform, and I'm going to do the hv.across where is cat array, and then if it is, cast it. And I think because I didn't export the across and where keywords, and that's because they're quite common words and I don't really want to pollute the namespace. But if you're very confident and you know what you're doing, you can just go using tidyverse, export these functions directly, and you will notice that I have here where is lowercase, but here I've used uppercase. Both are synonyms of each other, so they are just both will work. Technically, it's creating an object, so the where is more canonical way of doing things in Julia, but lowercase where is perfectly okay as well. So I've exported across and where, and you can see here I pipe iris into this transform. I'm doing an across, and this is my condition and the casting action, or equivalently in this case, transform across where condition, and I do a function where I apply the string function to every element of in the column to cast everything to a string. And the difference is, even if the column is a numerical column like an integer, this will still work, but this only works if the type is convertible to string, like the category here, because the underlying category is a string, so you can apply this, but this is more general. This will work for any column type. So that's it. This is how you implement across from dplyr in Julia, and I've made it into a package called tidyverse. You can use it to do across and where, etc. in Julia, just like you do in dplyr. Thanks. Bye.